All right, welcome to my third attempt recording this video. Hopefully it'll work this time. Okay, so we're talking about separations today, right? They are pretty similar in a lot of ways to elastic collisions, and particularly how you solve them. And this is the sort of steps. You'll see the similarities pretty quickly here. First step, momentum conservation equation, exactly the way you would do the elastic collisions. Second step, kinetic energy initial plus kinetic energy added equals kinetic energy final. Okay, this is the big difference. Before, with elastic collisions, they're equal. Now we've got some added in there. Still going to solve the momentum equation for one variable and substitute into the kinetic energy equation. Still going to solve that kinetic energy equation and get two answers. The big difference is that neither of those answers is going to be the starting velocity. They're both going to be some unknown value. And you got to figure out which one makes sense. Okay? And the way and sometimes it won't matter, and sometimes it will matter. We'll do an example of both here, but sometimes, depending on how the object's configured, only one of the options actually physically makes sense, and I'll explain that as we get to it. Okay. All right. So we've got our object here. It's a 10 kilogram, right? 10 kilogram object, and then it's going to explode into two pieces: a 3 kilogram and oops, not that, and a 7 kilogram going this way. And I want to know what that VA and VB are. So step one, momentum conservation equation. Well, beforehand, it's 10 times 0. All right, this is momentum initial equals momentum final. Afterward, it's 3 VA plus 7 VB. Let's go ahead and solve that. I've got 0 equals 3 VA plus 7 VB. Negative 7 VB equals 3 VA. And VA equals negative 7/3 VB. And for kinetic energy, right, we've got kinetic energy initial plus kinetic energy added equals kinetic energy final. So that's 1/2 times 10 times 0 squared plus 200 equals 1/2 times 3 VA squared plus 1/2 times 7 VB squared. This is 200 equals 3/2 VA squared plus 7/2 VB squared. And I'm realizing we should probably just multiply everything by 2 to get rid of the fraction. So 400 equals, and I'm going to go ahead and sub in 3 times negative 7/3 VB quantity squared plus 7 VB squared. 400 equals, this is 3 times 49/3, right? VB squared plus 7 VB squared. Okay. 400 equals, oh, this is over 9. It's my mistake, 9. It's going to be 3 when we cancel a 3 and a 9, right, when we factor that, but whatever. For now, it's a 9. This is going to be 16.33 VB squared plus 7 VB squared. You solve this, you're going to get VB equals plus or minus 4.14 meters per second. So let's say VB equals 4.14. Then VA equals negative 9.66. And VA, or VB, if VB equals negative 4.14, what happens? We get VA equals positive 9.66. Okay. Now, what's the difference between them? It's just which one's going left, which one's going right. So you can see here I drew VA going left and VB going right. So if we assume that right is positive, then the correct answer based on how we drew it is okay, But the other answer is also correct, right? This answer is also correct, based on, I mean, like it just, because we made up which one was going. So a lot of these problems will ask you for the magnitude, not the actual like velocity, because it doesn't make any sense to ask about the actual velocity because it could be either way. Okay. All right, a little more complicated one. We've got a 10 kilogram object with an initial velocity, and it's going to split into a 2 and an 8 part. And we don't know how they're moving. At least one of them's got to be moving to the right, but we don't actually know how they're both moving. So we do the same thing. Momentum initial, momentum final. 10 times 20 equals 8 VA plus 2 VB. 200 equals 8 VA plus 2 VB. VB equals 100 minus 4 VA. Boom. All right, but that's not as pretty. Like, remember the last one? It only had the didn't have like the constant there. Yeah, that makes it a lot easier to, especially when you're gonna substitute that in. But let's keep going. Kinetic energy initial. I plus KE added equals KE final. Kinetic energy initial is 1/2 times 10 times 20 squared. Kinetic energy added is 1,000 equals 1/2 8 VA squared plus 1/2 2 VB squared. Yeah. 2,000 equals 4 VA squared plus 1/2. No, sorry, we don't need the 1/2. Plus VB squared. Now we could substitute this in, and you can already hopefully tell this is going to get just nasty. It's not going to be nice. So instead, this is a case where you'd want to Wolfram alpha this, and you can see I already did that right there, right? Well, I would have if I had done this first part right. That's not 2,000. That's 3,000 now with the added part. I forgot to add the 1,000. It's 3,000. But here's the Wolfram alpha for it. Okay. 200 equals 2a plus 8b, right? That was that first thing. I didn't end up solving it, but 200. And 3,000 equals a squared. I actually flipped a and b, sorry, in this when I did it here. So let me actually change that, just so we're not confusing you here. There you go. Okay. Approximate forms. And they're kind of, I mean, again, not great numbers, right? But if I was going to do this, I would say it's either VA equals 12.9 and VB equals 48, or it's VA equals 27.1 and VB equals negative 8.3. So the question then is, which of these makes sense? Well, we're going to the right. Right is positive. So if we have VA is 12.9, A is this one, right? This is A, and this is B, and B is 48. Well, then yeah, B is actually moving faster than A. That makes sense. But if we do the other way, B is going left, negative, and A is going right. That doesn't make any sense. So it has to be based on how we drew it. If we draw it the other way, the other one would be accurate. So in this case, I'd have to tell you which side the 8 and the 2 kilogram objects were. Otherwise, you wouldn't know which answer was correct. And that's a problem because unlike the last one, it doesn't matter, like the same magnitude. I could ask you a magnitude and you'd have the same answer. But here it actually does make a big difference. Okay, so be aware of that. All right, that is it.